All right, let's dive right into this explainer and completely demystify the process of setting up a modern, containerized Laravel workflow on your Windows machine using Docker. If you've ever pulled your hair out over mismatched local environments, conflicting PHP versions, or that classic, dreaded, well, it works on my machine excuse, you are absolutely in the right place. Today, we're going to build an isolated, perfectly reproducible development environment totally from scratch.
Think of this as our technical cooking show. Here's the menu for today. First, prepping your Windows machine. Then, installing Docker Desktop. After that, writing the configuration files, building and running the containers, and finally, configuring Laravel and the database. Let's get to it.
Section 1. Prepping your Windows machine. Now, right off the bat, there's a pretty critical distinction when it comes to Windows editions. While Windows Home and Education users are restricted to running Linux containers, Pro and Enterprise users actually have the flexibility to run both. But hey, don't sweat it if you're on the Home edition. For our Laravel setup today, Linux containers are exactly what we want anyway.
To guarantee everything goes smoothly, your machine absolutely needs to meet a few specific hardware prerequisites. We're talking a 64-bit processor with second-level address translation and at least 4 GB of system RAM. But honestly, pay special attention to those last two requirements. You've got to have BIOS-level hardware virtualization enabled and ensure Windows Subsystem for Linux 2, or WSL2 for short, is actually turned on. Because without those, Docker literally can't create the isolated virtual environments we need.
All right, moving on to Section 2, installing Docker Desktop.
Getting Docker onto your machine is a super straightforward sequence. You basically download the executable from Docker's official site and run it. The most crucial point here, though, is Step 2. When it prompts you, you must select the Use WSL2 instead of Hyper-V option if it's available. I can't stress that enough. WSL2 gives you significantly better performance and way smoother integration for web dev tasks. After clicking through the rest of the wizard, just give your machine a quick restart to lock the whole shebang in.
Okay, so once you're booted back up, just search for Docker Desktop in your Start menu and let it initialize. Give it a minute on that first run, it's doing a lot behind the scenes. Then pop open PowerShell or your command prompt and type this quick little command, docker-version. If it spits back a version number at you, boom! Congratulations, your digital kitchen is installed and totally ready for action.
Section 3. Writing the configuration files.
So we start things off with the Docker file. Think of this as the ultimate blueprint for creating the isolated little bubble where your Laravel app is going to live. See, instead of manually, painstakingly installing PHP and web servers directly onto your actual Windows machine, we write a Docker file. It basically scripts out an automated, totally repeatable installation that happens entirely inside a container.
And here is how that Docker file actually layers everything we need. It's kind of like building a cake. We start with a solid base image of PHP 8.1 running on Apache. Then, we automate the installation of necessary system dependencies, stuff like GCC and zip tools. After that, we copy in Composer, which, as you know, is absolutely vital for managing Laravel's packages. And finally, the icing on top. We install specific PHP extensions like PDO_MySQL and GD, just so our app can successfully talk to a database and manipulate images. It creates a perfect, self-contained web server.
Now let's move on to our next recipe card and see how this builds upon what we just did. Meet the dockercompose.yaml file. If the Docker file is the blueprint for a single container, Docker Compose is basically the master orchestrator. It manages exactly how multiple containers talk to each other to form one complete functioning application.
We essentially divide our app into 3 distinct communicating services. First up, we have Laravel Docker, which builds right from our Docker file and maps our local port 9000 to the container's internal port 80. Second, we spin up MySQL_DB. That's an entirely separate container dedicated just to our database, exposing port 3306. And third, we throw in PHPMyAdmin on port 901. That gives us a really nice visual interface to manage the database. So it's 3 separate containers, all working together seamlessly as one cohesive unit.
Section 4. Building and running containers.
All right, this is where the magic happens. By following these 4 exact commands in your prompt, you bring the whole thing to life. First, obviously, navigate into your project folder. Second, you run docker compose build. This reads your recipes and downloads all the necessary software. Third, Docker Compose Up actually launches the containers. They're now running quietly in the background.
And finally, step 4 is literally like walking through a portal. Running docker exec with the bash command steps you directly inside your newly created virtual web server. It gives you a command prompt right from within the container itself. How cool is that?
Section 5. Configuring Laravel and the database. Now, while you're still inside that container's bash prompt from the last step, you're going to trigger this single composer command. Since our Docker file already did the heavy lifting of installing Composer for us, this command just reaches out, grabs the absolute latest version of Laravel, and sets up the entire file structure right there in our working directory. Once it finishes downloading and installing everything, you just type exit, and boom, you're right back at your normal Windows command prompt.
So the absolute crucial point in matching your brand new Laravel app to your database is updating your .en file. You'll need to open that file up in your code editor and make perfectly sure these variables match the exact values we set up in our Docker Compose file earlier. And hey, notice how db_host isn't just localhost anymore? It's MySQL DB, the exact name of the service we define in our Compose file. Docker's slick internal network automatically routes that specific name perfectly over to our database container.
Okay, with the credentials completely established, you simply send this command right from your host machine. Instead of logging all the way fully into the container, this command uses docker exec to just tell the Laravel Docker container to run a single specific task, PHP artisan migrate. And just like that, it builds all your database tables instantly. The connection is officially live.
The payoff is finally here, folks. Because of the port mapping we set up earlier in our orchestration file, you can now just open up your standard Windows web browser, navigate to localhost port 9000, and look at that. You will see the beautiful default welcome page of your fully live Laravel application.
And literally right next door at localhost port 9001, you've got full visual access to manage your data via PHPMyAdmin. You can verify the tables Laravel just migrated, add new users, monitor your data, basically do everything exactly as if it were running on a remote production server. Except, it's all safely sandboxed right there on your Windows machine.
Well, you did it. You've successfully conquered a totally complex setup, transforming a bare Windows machine into an incredibly powerful, isolated, and 100% reproducible development environment. You never, ever have to worry about the dreaded, "but it works on my machine" excuse again. So, with your local infrastructure perfectly sandboxed and ready to go, what incredible Laravel application are you going to build